Hello, thank you for joining. We are delighted to have you with us and extend our sincere gratitude for our valuable participation in this global educational gathering that brings together teachers, experts, and policymakers from around the world. Established in 2009 and in line with Her Majesty Queen Rania Al Abdullah's vision, QRTA is a nonprofit organization committed to supporting and empowering educators with the skills needed to nurture and lead future generations. The Academy remains committed to providing innovative, high quality professional development programs in Jordan and in the Arab world. The QRTA Forum stands as one of the Academy's most prominent annual innovatives, offering a platform for educators, researchers, and education leaders to exchange experiences, discuss emerging challenges, and inspiring meaningful change in education. This year's forum focuses on strengthening citizenship and values through education, featuring key themes such as active citizenship, education for sustainable development, digital citizenship, teaching and learning, and educational leadership. Before today's session begins, we would like to remind you that certificates of attendees will be provided, and we invite you to complete the feedback survey shared at the end of this event to help us continue improving our future innovatives. Please allow me to introduce Mr. Sufyan. Mr. Sufyan, he is a bachelor in fundamental mathematics and certified high school mathematics teacher, experienced in the international mathematics curriculum, certified in mathematics assessment and guiding student projects. With no further ado, Ms. Sufyan, you may start. Thank you so much.
Thank you very much. Do you hear me, please?
Again, Mr. Sufyan?
My voice is clear?
Your voice is clear, and your presentation is visual for everyone. Thank you so much.
Thank you very much. Thank you very much, Arnold. So, good morning and hello, everyone. I would like to thank Queen Rania Teacher Academy for this opportunity to exchange and share this important subject, which is developing critical thinking through interdisciplinary math projects in secondary schools and also in middle schools. So the workshop agenda is this. So we'll try to start with introduction and welcome, and also objectives. And then we'll move to what we mean by critical thinking in mathematics, of course, because this notion is very known in more than one discipline, of course. And then we will move to some scientific foundations, okay, to be more scientific and academic, to make sure that we have some science behind, some science foundations before we start to give, examples and so on. And then when we talk about that, we'll move to why interdisciplinary, okay? And then why problems? By projects, I mean problems, okay? In middle school, you can just consider projects just problems, not exercises. But in high school, things become more complicated. So you can turn it to a projects, guiding project for students. And then we move to what is a math projects, okay? Using the project-based learning. And we'll go through a lot of steps to show you how in practice you will give those projects to students to develop this critical thinking. Okay, and then we will assess, okay, evaluation and rubric design. This is very important. And we see two examples, okay? They will be really important, okay? And then question and answer season. All right, so I would like to say thank you to the Queen Rania Teacher Academy for this opportunity, and warm welcome to all participants. So we have very clear objective here, okay? So the first is understanding critical thinking in mathematics, okay? As I said, is a very large notion. Second is learn didactic and scientific foundations for project design, okay? Why this is true, why this is important, what's the science behind it, and then design those problems, those projects and assess those projects, because we are not in extra activities or summer schools. We are teachers and academics, so you are teaching those kids a lot of lessons. You have a curriculum to finish, so you really want to know how to design, but also to assess, okay, in a very, very careful way, those interdisciplinary projects. So I want to start actually by this question: is there really a link, this question for you, between math teaching, okay, as we know it, okay, lesson, and then give students a lot of exercises and so, and critical thinking, okay? I want just honest, point of view. Yes, absolutely, or maybe, or what do you think? Or there's no relation between the two? I will give you 1 minute just to answer. But thank you. Sarek from Jordan. Yes. Okay. Yes. Good morning. Okay. All right. Thank you. It's not a problem. Even if you are not a math teacher, this is going to be helpful, of course. Critical thinking is. All right. Most of the answers are saying, of course, that yes, absolutely. Now we are going to move to what we mean by critical thinking. So, of course, when we try to define this critical thinking notion in education cycle, of course, critical thinking is often defined as ability. Okay, this is really, really important, is ability to analyze and then evaluate and then synthesize informations rather than just recall facts, or just in the mathematical concepts only to do those calculations, okay, solving equations without putting them into concrete concepts, concrete contexts, concrete situations, okay? So you see there is a lot of steps here: analyze, evaluate, synthesize information or a problem, okay? This is the general formula of the definition, okay? So we would try to really move beyond rows of calculations to understand reasoning, okay? For example, a student using critical thinking might solve an equation and then explain, okay? By solving equation, I mean formulating or modeling an equation, okay? For example, you can say 2x plus 1 equals 0, and you solve this equation. This is just a calculating method, okay? But if you are really have this aim, have this goal of developing critical thinking, you would put this equation into a problem, concrete problem or interdisciplinary problem. For example, you may give him a biology problem, okay, that involves that equation, okay, or physics problem, that equation. And then he will modelize, okay, or reformulate that equation. For example, balance, okay, two masses, two unknown masses, plus 1 kilogram equals 7, for example, 7. So you're looking for this unknown mass, okay? So now he will reformulate this and then try to solve it, okay? This goal as solve the equation is integrated, of course. So students, and why there makes sense. So it's not enough to get the right answer as a that equation. Ask students, of course, they ask why the answer is right, and they check for alternative strategies, and they try to apply concepts to new situations, okay? And we will see in Bloom taxonomy terms, okay? I'm going to talk about that now. We're pushing toward the upper levels, which are analyzing, evaluating, and creating, not just remembering or applying blindly, okay? Okay, a student can be good calculating, solving things, but if you put those same equations into concrete problems, he will be stuck. Okay, so I know one educator, he published a very nice note. He said critical thinking is an essential skill, okay, an essential skill needed for students to be able, one, logically process concepts and become effectively problem solvers, because life gives problems, okay? Every job, for example, engineering, medicine, and so on. So it's sorry.
Thank you. Again, Sufyan, press on it and continue.
All right.
Do you need any help, Sufyan? Just press on the icon.
So I have some notes here that I want to use.
It's okay. Keep on going, Sufyan. Keep on going. Thank you.
All right.
Okay.
So as I said, in practice, critical thinking in math involves, habits like asking. Okay, so we are moving behind those direct questions. Okay, just to calculate, to manipulate. Okay, those direct questions from putting the same goal into concrete problems. Okay, those concrete problems involves those skills, which is asking why and looking for alternative, okay, and logically process concepts and try to be the problem solvers, not only calculators. Okay, so this is the main idea of this talk. So today, whenever we say critical thinking, you can just consider or imagine students actively reasoning, okay, not just calculating, actively reasoning, debating, and reflecting in the math class using those problems. Okay, and it's the opposite of just plugging numbers or applying blindly the formulas. Okay, there's something more than just calculating blindly. All right, so now we need to see or to look at the didactic and scientific foundations. Okay, so of course we want to be academic and scientific, and we want to make sure that this has some scientific foundations and not only just our own opinion. Okay, so we will start with Brosseau didactic situation. This is a very famous subject in didactics, mathematical didactics, of course, I mean. The Brosseau is a French theorist, of course. He introduced this theory, actually, it's not only an idea, it's a theory of the didactic situations, essentially, which is a classroom scenario engineered for learning. Okay, in this situation, you put students into a situation. There is something called didactic contact between the teacher and the students. The teacher devolves, okay, which means devolution, all right, devolves problems into students, and students work to solve them. Okay, so devolution means handing over responsibility, of course, in a careful way. In a project, the teacher so you're looking now at the difference. Okay, we're not talking about exercises, we're not talking about blind calculation, we're talking about projects, we're talking about devolution. Okay, you're devoting something to students and you leave them, okay, to solve that by their own. So in this project, the teacher might pose a real problem, okay, a real world or concrete problem, and then students shows how to really talk it, okay, rather than just following strict guidance. Okay, you're not giving them those auxiliary questions to help them or something. You're just giving them this concrete problem, and they will start to handle it by their own. So Brosseau reminds us that the way we present tasks shapes understanding. And this is what I'm trying to say, because if you have, for example, a problem and you have a lot of auxiliary questions, you're helping them. So they are not thinking, they're just following you. All right. So this is the difference. They're just following your helps. They are not thinking. Okay. They are automatically following those logical steps. So there is no goal of giving them those auxiliary questions. Okay. So just you put the problem, the concrete problem, which is live version. All right. So for example, if I give a completely open problem with no guidance, okay, this is really important. For example, calculate the radius of the Earth using trigonometry. This is one example, okay? Or you would choose for example, one offer or another, okay? Or calculate the distance between two cities. This is the general version, okay, of what I mean by problems or Brosseau situations. All right, so you give completely open problems with no guidance. Okay, this is really important, and many students may struggle. Actually, most students will struggle or get lost or blocked. Okay, so we must scaffold, introduce some problems or some auxiliary questions, but not at the first time. Okay, so this model encourages this alternative flow. The teacher present a challenge, evolution, as we said, students try ideas. So students will think, okay, if you are giving them from the beginning those auxiliary questions and very clear step, they are not thinking. As I said, it's really important. They're just following your steps, following your questions. They are automatically thinking, okay, not creatively, okay? They should have their problem with the one. So the teacher, after that, okay, try to formalize or correct misunderstandings. Now we are trying to helping them, okay? But the first, you just give them this problem and leave them, okay? So this happens over weeks, of course, and we see periods of open exploration, teacher feedbacks, and then class discussion to summary. Of course, this in high school, but in middle school, as I said, problems are more easier. This is the first foundation, which is pursue situation theory, okay? And the main idea, of course, is to give them concrete problems with no guidance. So they will think, they will struggle, they will search for their own pathways, okay? And they will think creatively. They will think, okay? They are not following your steps. They are not following your help, okay? So don't help them. Give them the problem at the beginning, of course. And then you, after that, you can correct misunderstandings. You can give them auxiliary helps and so on. So, all right. So the second foundation or second scientific foundation is Chevallier's didactics. So this theory view math knowledge as a human activity, okay? And this is actually essential because math is mostly seen as, very abstract. Students say, who needs math? Math is abstract, it's for nothing because it's so far from the daily life, all right? So Chevalier says that the mathematical knowledge, okay, even if it's abstract, it's come from reality, it's a human activity. So the key unit is connect set of tasks, techniques, and theory, okay? And you can think of it as, for example, when we teach geometry, there is not just the one procedure, okay, or one way. There is a whole ecosystem of problems. For example, finding area, proving similar triangles, and then this is the mathematical part. And then, of course, there is methods, which formula to use, which constructions, the right constructions or wrong. And then there is explanations, why formulas work. So this is the human activity, okay? It's abstract, yes, but the human activity is in the heart, okay? And of course, this reminds us to consider how mathematical knowledge is organized, okay? And I've done research on this when I was an intern teacher about what's so-called in French, les démarches métacognitives, la métacognition, la connaissance, what's behind knowledge, okay? What's there for students, of course, is some students have this kind of strategies, okay? And some students have this blind pathways. They're just gambling, for example. I'm sorry for the term, but they are just gambling, okay? They think arbitrary and they try to find the right way, but they don't have this clear strategy, okay? So Chevalier reminds us to really develop this organized knowledge. So to train them to ask what are the tasks in our projects, what technique I will use, okay? And also remember the didactic transposition, how the pure math concepts get simplified and contextualized in school, okay? And this is the importance of those problems being concrete, okay? And taxonomy, okay? And this is really important. Before we move to formative assessments, this is another scientific foundation of this interdisciplinary math projects. So now we are starting to see the importance of interdisciplinary, okay? So when we say put mathematics into a concrete world, what we have in the world, what we have in daily life, we have biology, we have nature, right? Biology, geology, we have physics, astronomy. So physics, astronomy, biology, all those fields are representing that word interdisciplinary, okay? You are not in your own discipline, mathematics, concrete, Okay, sorry, abstract math. No, you are in the world. In the world, what we have science behind. Of course, we have physics, chemistry, and so on and so on. So if you are trying to make math concrete, you will be forced to really formulate your problems from physics, from biology, from computer science, and so on and so on. All right, so this is really important to know. So interdisciplinary means you will find yourself really formulating your problems from other disciplines. And of course, then you can collaborate with the physics teacher, and we're going to talk about that. Okay, so Bloom's taxonomy, and this is very famous in Canada, especially, they're talking about this, les niveaux taxonomiques. We have 6 levels. So remembering, okay, and then understanding, applying, and analyzing, and evaluating and creating. Okay, so critical thinking, of course, it's very clear. It lives in the top tiers, analyzing, evaluating, and creating. Okay, so our project should not just ask what is, for example, 7 multiplied by 8, but you should require or put that 7 multiplied by 8 into these 3 steps by formulating a problem, which is analyzing, evaluating, and creation. Okay, and I will give you one interesting example of Bloom taxonomy, okay, in the next slide. And then, of course, we have the famous foundation, scientific foundation, which is formative assessments. Okay, in a project, of course, or problem, assessments isn't just a final quiz. Okay, it's not for to judge. Okay, and this is very important. In French, they have these famous sentences. They say l'évaluation au service de l'apprentissage, evaluating in the service of teaching. Okay, you are teaching them. Students learn from assessments. Okay, they're not being judged. Okay, so this is why we call it formative assessment. You are forming them through assessments, through evaluation. Okay, you are not judging them. You are not classing them. You are the first. You are the last one. No, you are teaching them through those formative assessments. Okay, and of course, this means looking at work in progress and guide the students through those problems. Okay, so this is the third foundation, okay, for choosing and working with this interdisciplinary math problems. Okay, and formative assessments also encourage students to question, okay, this is why we call it formative assessment evaluation. Why did you choose, for example, that approach? Why did you choose that method? Is there any other method? And so on. So maybe we can talk about another foundation, okay, which is engagement and context. And maybe I mentioned this before. So the science that we have today is reminding us to really take emotion and social engagement matters. Okay, so when we put those problems into, for example, physics, and you may have a lot of students who likes physics, so you are making them engaged. Okay, if you are putting those problems into, for example, those interdisciplinary problems into, for example, chemistry or biology, you have a lot of problems. So in your class, you can actually create a lot of problems, okay, a lot of interdisciplinary problems, sorry. And every problem, for example, one in physics, one in chemistry, and then you are giving students the ability to choose, okay, to make a choice according to their preference. Okay, now let's move to this slide. It's very important because I was reading this didactic course by Mr. Saeed Abu Hanifa. He is a very famous math professor, okay, here in Morocco and also in Canada. And he had this problem with exercises, okay? So by problems, I mean, of course, projects, okay? As I said, problem or projects. And exercises means calculations, okay? So you can just ask yourself, what are the differences, okay? If I'm given students exercises, I will develop a lot of competencies. But if you are given problems and projects, we are going to see a lot of differences. Okay, so if we are talking about nature of the two, so an exercise, of course, is routine practice of a known procedure. By a known procedure, I mean known steps. For example, solving that equation to x plus 1 equals 7, okay, where x is 3, of course. So the steps are very known, okay? The student doesn't need to think, doesn't need to question, doesn't need to do anything, okay? Taxonomy, Bloom's, forget all that, okay? But when you give students problems, now it's a new situation, needed that metacognition, okay? What's behind knowledge, a strategy, okay? A choice, question, and so on and so on. So this is only from the nature side. If we're talking about knowledge, an exercise mobilized recently taught technique. As I said, there's very known steps to solve an equation, for example, or multiply numbers, okay, or division. So it's very known. They have it, okay? They just need to recall that knowledge and apply it blindly. But the knowledge associated with a problem may combine, okay? So for example, use two different techniques or two formulas or algebra and geometry, especially in physics or astronomy, or activate several knowledges and modeling, okay? So problems always try to force students to think and to really be creative, okay, to question and so on. So, but exercises does not. Of course, in the Arab world, and this is very sad, we use, of course, only exercises, okay, and this is a point that we'll come back to. And now the interesting point is student reaction. Of course, there is no reaction in exercises, of course. So recognizes procedure. Okay, I know how to calculate. I know how to solve the equation. I don't need to think. I'm not motivated. Okay, so you know the exercise doesn't really develop any important or clear, okay, competencies. But problems, the student doesn't know immediately how to proceed. Okay, so he's stuck. And we talked about that in those scientific foundations. This is why that section was really important. We're talking about this part is didactic of math, all right? So the problem, he doesn't know. So as I said earlier, he doesn't know immediately how to proceed, how to start. So he will start to think. But if you are giving them those auxiliary questions, you're helping them, so they're just following you, okay? So just give them this general, okay, version. What is the radius of the Earth using trigonometry? Or calculate the unknown mass and so on, and let the problem like that. And then, of course, you can just guide them after, okay? Of course, we can compare the two from pedagogical point of view. So an exercise is automatization, okay? Skill consolidation. By consolidation, I mean something that students already have, okay? And you're just reinforcing that skill, okay? But when we talk about problems or projects, so they are thinking, okay, as I said, because he doesn't know the path. He is looking for the path, so he's thinking about, okay? It's not like solve this equation. You are given that equation to the student. In a problem or a project, he should really formulate, okay, that equation. He should build it, okay? And this is a reasoning and problem solving, okay? Should formulate the equation and then he should solve it, okay? So problem solving means create the problem, create the equation, for example, like the balance example, modeling, and then creativity. Creativity means, of course, he can ask a lot of questions, and I will talk about this. Now we need one example to understand this comparative table. An exercise is like divide these two numbers, okay? And then the students get 20. And of course, there is no critical thinking, there is no creativity, and he doesn't need to be that smart, okay? But you can put the same question, and by the same question, I mean this, 160 divided by 8, into a concrete, okay? And I like to give simple examples to show you that you can develop critical thinking not only by those high school complicated, you don't just from simple questions you can develop critical thinking. And the first project that we're talking about later, okay, soon, is about this idea, okay? So just be confident as a teacher or as a principal, you can develop this critical thinking through very simple lessons, okay? You don't need to teach them Einstein theories or complicated math theories to really create this amazing project. No. For example, I have 160 eggs. Each box holds 8 eggs. How many boxes do I need? So there is no high school here, even middle school. So you just need to divide. So you are giving students the same question, not by the exercise version, by problem version. So he will start to think what we have, he will start to organize data, he will start to reason, his reasoning process. Okay, so I hope this example really demonstrates the important difference between an exercise, okay, and problem. And of course, we have a lot of types of problems in didactics, and I don't want to go through this because they are quite similar. Okay, so we can ask now, of course, why interdisciplinary math projects and why we want to go interdisciplinary. Okay, as I said, we have the first reason, and we're talking about mathematics. Of course, it's not isolated in life. Of course, mathematics comes from life. Okay, and there's projects that cross into science, for example, economy, physics, chemistry, and so on, and or for example, astronomy also. So they are really understand that mathematics, of course, comes from those daily life disciplines. So you will not have this famous question, who needs math? Why math is important? Because you are formulating, constructing, and evaluating your mathematics content, from daily life situations, from real life, from computer science, from physics, from astronomy. Okay, so you will not have this problem. This is the first reason. The second is, of course, deeper conceptual understanding. Okay, and the project-based learning says that we're combining the application of mathematics, okay, content and notions with today's world. Okay, of course, today we need problem solvers, we need communication, we need collaboration. As I said, you can give them a set of problems, they can choose which problems to work on, maybe in physics, maybe interdisciplinary in physics, chemistry, computer science, and so on. So student revisit concepts in a very specific context, like chemistry context, or physics context, or computer science context, and so on. So which of course depends their understanding even for physics. Okay, and of course, for instance, we'll talk about designing, for example, a garden might involves area, perimeter, or for example, this equation example for the balance, so, or even biology. So here we're trying to apply math to real tasks, okay, concrete tasks. And this, of course, forces students to transform and link their skills to truly concrete situations. And as I said, engagement and motivation, of course, giving them those, concrete, concrete versions of just calculate and then prove or something. You can move behind that, okay, to concrete problems, so they will get motivated, especially if they like physics, if they like chemistry, and so on. So motivation is of course one important subject. Also, the most important skill for the future, which is problem solving. Okay, not exercises solving. There is no great thing in teaching exercises. Okay, so in summary, this daily project, those interdisciplinary projects that I'm talking about, will make your mathematical content meaningful, concrete, challenging, engaging in a positive way. Okay, so your class will be positive. So you will have this curiosity going in your class, and this is of course the goal. Okay, so this is the reason why we are talking about interdisciplinary. Okay, a lot of disciplines. Okay, because math being concrete comes from real world, and what we have in the daily world, we have only physics, chemistry, so we have other disciplines, okay, indirectly. Now, what is a math project and how to give it to students? Of course, as I said, math project in middle school, you can just think of it as a problem, as I said, not exercise. And it's a real world task where students investigate. So this is the first step, investigate, not try to solve. They will investigate, which means they are thinking, okay? An exercise, you don't need to think. You have a lot of steps, you solve them, and you are done. Okay, investigate an open question, okay? Not precise question, not auxiliary questions, using mathematics and reasoning, okay? So how can we give it to students? Of course, there's a lot of ways, but what we do actually mean by a math project is an extended task. Okay, so you can start, of course, with some exercises, with some calculating tools, okay, to train them, and then you can move to those concrete problems. Okay. For example, I know, and this I have to give to students, of course, as I said, if you are, for example, in middle school, you can give them those problems, okay, just problems, concrete problems from real world. But in high school, you can also use the project-based learning. This is what I mean by PBL, inspired steps. Okay, they are very known to you. Or in middle school, you can just use formative approach, which is giving them a concrete problem and they will try to solve it. Okay, so now evaluating. Okay, so when we talk about evaluation, as I said, or assessment, by evaluation, I mean assessment, we are in schools, okay, middle school or high school. So we are not in summer school, of course. So we need to align those problems, those concrete problems into our objectives. For example, I am teaching equations, okay, for the 7th, the 8th grades. So I really need to align these problems or projects with my objectives, okay? And the second is analytic rubrics. For example, you can use your own, and then formative checkpoints, and for student involvements. Of course, by student involvements, I mean they can self-assess, okay, or correct each other solutions or compare their solutions, and transparency and evidence. Of course, you don't need to classify the results, okay. The goal, of course, is to develop this critical thinking, okay, aim, and you can just tell them that this method is not working, and you can discuss why it's not working, and so on. So put at the center the techniques, the goal, and not the marks. Okay, all right. Now we had this project number one, and now we are moving to practice. Okay, so this, I don't know, we have 30 minutes maybe. So we're talking about the scientific foundation. Maybe that was a little bit hard and a lot of theories and so on. So now we will put all what we're talking about into a concrete, practical situation. Okay, and I want now your opinions about this project. For example, this project, of course, is for a middle school. And as I said, you can develop those skills, okay, by very simple lessons, okay, not supernatural, not complicated. For example, probability in ES or E level, E2 level. No, you can just use a very simple notion like equation or inequality, like this problem, to really develop a very important skill such as the critical thinking. Okay, so we have this sports club, sorry, offers two payment plans. So the first is $10 per season. Okay, you pay $10 and then you enter. The offer B is $100 membership card, okay, per month, okay, plus $4 per season. And the question for students is, which is the better deal for different users? Okay, so the question is, which offer will, this is a question for you, and you can just write me here in chat which offer student will choose. Your answer kindly, or put your mic on and tell me what you think. If you could, of course, put your mic, share your opinions, and we can discuss. I really want to know what you think about this. So I will stop for 1 minute or two to give you a chance to share.
Mr. Sufyan, your mic is mute. Yes, now
Yes,
we can hear you. Yes.
Thank you. So which offer will student choose and why? I want to know why. The psychologic reasons. Now the voice is clear. B is more economical.
Yes.
Okay. Of course, please kindly, I want to know which offer will students choose, not you. Okay. So students will think B is the best choice. Okay. A, probably A, because for them it's okay. It's more economic. Yes, that's the famous reason. All right. A for students. Yes, for students. I'm asking only for students. Okay. Will ask me how many seasons. Okay. This is a very nice question. I will come back to that. Thank you. B is better. Okay. B because it will possibly to get official membership. Maybe if you need less. Great. Okay. Mr. Khalid asks if he can talk. Mrs. Al-Anno.
Yes, Mr. Sufyan, they can raise your hand and unmute themselves. They have the access for that.
Mr. Khalid, you have the access. You can talk. You can put your mic on and share your opinion. It's really greatly appreciated. Just unmute your mic, Mr. Khalid. B is better. Okay. Hakam Al-Khatib raised hands. You can unmute your mic. I think you have access. Do you have access, Mrs. Lanoud? Yes?
Yes, they do.
You can just unmute your mic. You have access.
Okay. Can you hear me now, Doctor?
Yes, yes.
Yeah, I'm actually a teacher of English language, not
Yes.
a math teacher, but I have some ideas about your question, so I have to answer your question. I think it depends on their needs. That some students will choose to pay $10, for example, for the system, and others will pay 100. Depends. The first one depends on their needs. I guess that they will not need all the systems. For example, we have a student need a specific class in a specific subject. He will choose to pay just $10, and it depends also on his economical situation, if he has the money to pay or not. Others will choose the membership to pay $100 for a card. Yeah,
For students
my
who
idea.
will not, for students who will not choose the offer B, for example, for you, what are the psychological reasons, in your opinion?
Psychological reason.
They see 100, they see 10.
Yeah, if, as I said, let's say poverty depends on poverty. For example, they don't have they have their calculations when they get some ideas or get some plans or to do something. They think more and more.
Exactly. Is
it clear?
Yes, of course.
Thanks a lot. Thank
Thank you very much.
Thank you.
All right. Is there any opinion? Someone wants to talk? Please go ahead before we move to the second project. It is good for tasks. Yes, of course.
Mr. Sufyan, we have Marwa. She raised her hand.
Yes, please, Marwa. Go ahead. Just unmute your mic. We'll take only this opinion and then go. Marwa, you can go ahead, please.
Yes. Hello, sir. I would, as a student, according to my experience in my class, my students would ask me how many sessions. Then they would probably discuss their own memberships that they have in their own clubs. As a differentiated class, I feel the ones who would be more into the problem would ask me these questions, and the ones who need more scaffolding will be doing offer A, because it just looks like less words and less numbers to deal with.
Yes. And do you think, Marwa, that media uses this kind of they
Yes,
are
definitely,
trying to,
because I've been a business teacher as well. So
yeah,
we've learned about promotional technique tactics.
yeah,
So usually if in this kind of question, I would integrate, interdisciplinary approach by integrating business with this.
exactly. So we are talking about developing critical thinking. So we will try to form a generation which cannot be manipulated by media effects, what Noam Chomsky talks about. So thank you very much, Marwa. Thank you. All right, now we can, of course, sorry, I can just reduce this chat button. And of course, my goal from proposing this project, this is one example. There is two reasons. The first, it's very simple, okay? I mean, the mathematical knowledge that they need is just inequalities, okay? But the goal, the second, of course, is to discuss the reasons. Of course, the first is the fear of loss, okay? They reject the $100 because it looks like a risk, okay? So their choices are based from psychological decision, fear of loss, and not mathematics and not logic, okay? Not statistics. I was going to discuss. Also, guessing instead of reasoning. This is important. And please, when we give this interdisciplinary problems, as Mrs. Marwat mentioned, try to have this discussion section, okay? Discuss the reasons, okay? Don't say, okay, this answer is right, correct, this is wrong. No, discuss why, okay? If student says, for example, I would choose the offer A, you can discuss the psychological reasons and link that into media, into business, and so on. So this is the goal, okay? Because our aim, of course, is to form a generation which is not easy to be manipulated, okay? And the second, of course, as I said, is guessing instead of reasoning, okay? Which means we'll learn that intuition is not always correct, is not always right, okay? Intuition is good, but it's just to take it at mind, take it as the first step, okay? And don't trust it 100%, okay? This is very important subject. So you see, this is just a very, of course, also one reason that I'm forgetting is overgeneralization, because they assume one option is always cheaper without analyzing the context, okay? To see a lot of suggestions. Okay, so the important idea here is from a very easy mathematical notions like inequalities, we can talk about business, we can talk about media effect, as Mrs. Marwa mentioned, and so on. So, okay, so just trust yourself. And of course, you don't need to give those projects for every lesson, okay? So critical thinking is important, yes, but it's not all, okay? So maybe you can, for example, find a very nice interdisciplinary projects for every lesson, for example, but you can, for example, give 1 or 2 projects per semester. That's enough, okay? And of course, if we want to use some mathematics, this is the method. So the cost number 1 is $10 multiplied by the number of seasons. Okay, the second is 100 plus $4 multiplied by how many seasons they chose. So we want the offer A to be less. So we formulate this inequality, we solve it for n, and we find that if the number of seasons is less than 16 seasons, so they should choose the offer A, okay? And if it's more than 70, then B becomes more good for them, okay? And of course, please don't forget, discuss those psychological reasons behind their choices. It's very important, and link that to media effects and so on. So I'm talking about this specific project, okay? And this is the suggested errors and misconceptions that student will learn to avoid, because I think Mr. Hakam Al-Khatib has something to say. Please go ahead. Of course, you can have your own schema to discuss with students. Mr. Al-Khatib, you can just unmute your mic and go ahead if you have something to say, please.
Yes, can you hear me? Hello?
Yes, we can.
Yes,
Yes,
yes.
we can hear.
Okay, again, I'd like to ask my question.
Yes.
Is poverty one of the psychological problems that students can face? In this case, please tell me, does it match or not?
Sorry, again, please.
Yes.
I don't hear you. Please, can you please repeat the question?
Okay, my question is, again, in this case, can we consider poverty one of the psychological problems that students have to choose one of these cases?
Yes, it's the fear of loss, okay? Because they're just affected by this big number, which is $100, okay? Membership plus $4 per season, okay? They are just,
thank you.
Okay, this is the reason. Okay, they see 10. This is why I choose the small numbers. Of course, you need to be careful as a teacher or as someone who teach. Try to choose these very different numbers to really create this internal fear. Okay, they see this 10 is very small. Okay, it's very economic. Okay, $10 per season. Okay, it's more economic, but $100 membership card plus $4. Seems really complicated. Yeah,
Thanks a lot.
Please, thank you. All right, this is, as I said, suggested schema, okay, of errors and misconceptions that you can use to, to discuss those errors and misconceptions that students will make, okay? As I said, trusting their intuition. Intuition is good, but it's only the first step, okay? This is where critical thinking appears because, as I said, one of the important axes of critical thinking is evaluating, questioning. Am I right? Okay, I'm choosing $10. Okay, that seems economic, but they really should have this questioning themselves. Okay, so they will own the question. Okay, not being owned by the question. The second project, I don't know. We still have time,
Yes, you do. About half an hour.
Yes, thank you. Okay, the second project, it's for high school students. It's a very famous problem. You are on a game, okay, in a game show. You have 3 doors, okay. Behind one door is a prize, okay. And the other 2, of course, are empty. So you choose a door, but it's not opened. The host, who knows what is behind each door, opens one of the other 2 doors, revealing it empty. You find nothing. So you are left with 2 doors. You are then offered a choice: stick with your original door, your original choice, of course, or switch to the remaining closed door. And the question is, which door student will stick with their original choice, or they will switch? This is my question. And of course, we're not here to discuss the exercise side, okay? I mean, calculation side, but the critical thinking side, okay? Why they will not switch? Because I don't know, you can just tell me and then we can discuss. So in your opinion, student will switch or not? Okay, we have 3 doors, A, B, C, for example. Behind one door is a prize, and the other 2 are empty, okay? And we open one door and find it empty. So you will ask students if they would, stick with the original choice or switch to the second door. So what do you think student will do? Student will stuck on the original door. Okay, thank you, Amal. And for the reasons, what do you think about reasons? I can give you 1 minute to think about it. This is a problem. Please, you can turn your mic on and share your opinion about this. And just for teachers from other disciplines, this project is about probability, of course, it's clear. You can imagine, of course, 3 doors, A, B, and C, okay? And behind one door is a prize, okay? And you choose one. So the probability that you win, that you choose the door with the prize, is 1/3, okay? It's 33%. And for the 2 doors left is 2/3, okay? And when you open, for example, let's say C, and you find nothing, the first door is 1/3, and the second is 2/3. Okay, and the question, of course, is if you stay with your first choice as a student, your win chance is 1/3. And if you switch to B, okay, because B and C has 66%, okay, so your win chance is 2/3. So they will change or not. So what do you think? And if you could tell me the reasons. I think they may stick with the original door. Why? For example, because most students will not switch. Stick into his first option. Most students would, because it feels like both remaining doors have exactly 50-50. This is exciting. This is important. Thank you, Elena Martilli. Thank you very much. They will think that it's 50-50, and that's not right. The reasons, okay, the reasons why, because we're talking about critical thinking, and we talked about those 3 axes of critical thinking. If you could involve those 3 axes here, questioning, evaluating, and so on. So please, you can just unmute your mic and share your opinion, please. Asif, please go ahead. Just unmute your mic. We are not hearing you.
It's mute
Now
like
it's
this.
good. Now it's good. Go ahead, please. Please go ahead. Manal, thank you very much. Exactly, yes. Okay. Curiosity of the student to switch door. They don't like one they have. Yes, maybe. Okay, of course. The first choice 1/3, the host open one door, the empty zones. Yes. So in summary, I don't know if, right? And as I said, the most of students will not choose to switch again because of fairness. Okay, 2 doors left equals 50-50. Okay, so I don't need to switch my choice. So this decision is based on personal guesses, okay, intuition, okay, and you can teach them that intuition is not always true. Okay, you can be manipulated by media using this, for example, the 10-100 trick, okay, just to manipulate people, as Mr. Al-Khatib said, or Mrs. Marwa. Okay, so you are here to discuss this psychological reasons behind their decisions and make them aware of their decisions. Okay, so the first is fairness, of course, overconfidence. Okay, many sticks with their intuition even after evidence shows it's wrong. So also we're going also to this personal decisions, personal conceptions. Okay, and they are not basing their choices, the decisions, using statistics. Okay, using probability, using science, using reasoning. They are just have this personal intuition, personal guesses directed by their fear, and so on. So this is math, this is interdisciplinary problems, and you can see now how many skills you can really share with your students using this example. So what are the skills that you can develop? Of course, as I said, the common errors. Okay, sorry, put this here. The common errors, of course, is intuitive fallacy, overgeneralization, personal guesses, and so on. And I am putting these errors here in green to show you that errors are not a problem. We learn from errors, okay? This is why I'm saying after those problems, after their answers, sit and discuss with the students their psychological reasons behind and so on. Okay, that's the goal. Of course, those are the common errors. Okay, now what you will gain, of course, as critical thinking skills, reflection, as I said, questioning. Okay, they start to question. An exercise doesn't allow you to develop this skill to question because they have this very clear. Okay, they don't need to be that smart. Okay, they don't need to be that brilliant. Okay, they're just following your help, following your auxiliary questions, and there is nothing to develop there. Okay, problem solving under uncertainty. This is important. I like this word, uncertainty. Okay, Because for exercises, the question is very simple. It's clear. Okay, the path is clear. In problems, it's not. Okay, critical reasoning, for example, in second projects, as I mentioned, they can start to do this analytical reasoning. I switch, say, with my first option, and so on. So this is another skill that you can develop with your students. Okay, so now if you have, please, some questions. But before, I have this call to action. In the Arab world, in or all over the map, all over the world, please, this is, I'm just, a young teacher. I'm just starting my career, but I am participating here for one reason: to tell you, choose problems, not exercises. Okay, if you want to teach them how to solve an equation, start with that, but then you can give them projects, you can give them problems to develop this critical thinking skill, as I said, because it's challenge their intuition. Okay, make them conscious, because sometimes they are manipulated by their feelings, by their personal conceptions, and so on. So, and they're not basing, they're not making their decisions with statistics, with reasoning. Okay, they're just guided by their emotion, by their guesses. Okay, so challenge their intuition. Connect math to physics, chemistry, economy. Okay, English maybe, because we can, as I said, manipulate students using just numbers, 10 and 100. Okay, this is a psychological trick. Okay, so you will have your student really aware of this kind of tricks that media actually use a lot. And also use real world projects. Okay, don't tell them about butterflies, tell them about physics, chemistry, computer science. Okay, not just exercises and blind calculations, abstract calculations. And the goal, of course, is to develop this critical thinking. Critical thinking consists. And I was writing yesterday this article that I want to show you. Please, just a minute. I'll try to share it. Can I share this article, Mrs. Landau, if I may?
Yes, you may.
Thank you. It's about, sorry, share. Okay. Is it clear for everyone?
Yes, it is.
Yes, thank you. So I was writing this. I will share it on LinkedIn. Okay, my LinkedIn account is Sufyan Boulahia. And also I will try to send it to Queen Arlene Teacher Academy to share it. Is developing critical thinking is preparing generations for the future. And by future, I mean AI. Of course, this is an important subject and a new evidence, okay, new proof of why we need problems, why we need interdisciplinary problems. Because AI will replace calculators, okay, not thinkers, okay. Okay, thank you. I have only 5 minutes, not thinkers. Okay, so this is a new evidence why we need to develop this critical thinking exercises, create just calculators, not thinkers. Okay, the world is changing, of course, and the future belongs to thinkers, not memorizers, not calculators. So this is just an article I will share. I have here a lot of interesting ideas, and let's come back to our presentation. And if you have any question, please go ahead, turn on your mic, and I'm ready to answer. Please go ahead. We have only 4 minutes for question and answer. Please go ahead. Thank you, Mr. Ahmed Mohammed. If you have any question, thanks.
Mr. Sufyan, I have a question. Yes, Mr. Sufyan, my question was, how can you apply critical thinking from the earliest stages, from the elementary stages, so that it's not that difficult in the middle and the high school? Because we have, for example, we take the HMH curriculum, which has the Into Math and the Go Math, which has a page for Think Smarter questions, which we usually feel that the Think Smarter questions are a little difficult for the students because of the critical thinking involved. How is the best way to approach this, apart from the presentation that you have given for elementary class level?
Yes, so for elementary, of course, kids doesn't have to have this critical thinking actually, because media and jobs, we're not hiring kids, okay? So what we can do is to develop these problem skills, which is reasoning and evaluating and question assumptions. For example, this example that Don't give them, for example, 160 divided by 8, but given this concrete problem, okay? So as I said, critical thinking, it's not this one unit, okay? It's evaluating, questioning, don't trust your intuition, don't trust your guesses, be aware of your psychological manipulation barriers, okay? So there's a lot of access, and you don't need to cover all those access. You can just cover in elementary school 1 or 2. So you are preparing them for middle school and high school for other access, okay? Am I answering your question?
Thank you so much.
You're welcome. If you have, yes, Elena, go ahead. Just turn on your mic.
Hi, good morning, everyone.
Good morning.
I completely agree that real-world connection are essential in math education. However, I believe sustainability challenges can provide even deeper and more purposeful contexts. What's your view on that?
So, as I said, by problems and projects, I mean interdisciplinary problems from physics, from chemistry, okay, and computer science. For other disciplines, I don't have actually a clear view of how can we apply this critical thinking from them. But of course, as I said, this example of physics, chemistry are just examples. I'm not limiting you. I'm just giving you examples where you can be inspired to formulate your problems from economy, for example. I'm not mentioning here economy, but Mr. Al-Khatib, I guess, he was mentioning, or Mrs. was talking about this economy and marketing manipulating techniques. So, of course, it's up to you. You can just believe in yourself and try to be inspired from other disciplines. The goal is to develop this access that I'm talking about, okay? This is the main idea of my presentation, not exercises, not blind calculations. Integrate those calculations, integrate those blind calculations into a problem, concrete problem, so you can develop a lot of access that will create a conscious generation. Am I answering your question?
Thank you so much.
Thank you. If you have another questions, we have only 2 minutes. Just turn your mic on. Well, I think no questions. The chat. Maybe let me check. Thank you. Welcome. Thank you. Thank you so much, Dana.
Thank you so much.
Thank you. You're welcome.
Mr. Sufyan, thank you so much.
Thank you very much, Mrs. Lanot.
As we conclude this inspiring session at Queen Rania Teacher Academy Forum 2025, we extend our heartfelt appreciation to all participants for your active engagement and insightful cooperation. We hope this experience has enriched your perspective and equipped you with ideas and tools to foster your values-based education in your schools and committees. You will receive your certificate of attendees via email soon, and we will kindly encourage you to complete the feedback survey to help you enhance future events. Thank you for being part of this forum. We are looking forward for welcoming you again in this coming events in QRT. Thank you so much for attending, and thank you for this fruitful session.
Welcome. Thank you. Thank you very much. Thank you for your